Okay, so here's your next screencast for nuclear chemistry, and in this one we're going to talk about how to write the reactions for alpha decay, alpha capture, beta decay, and beta capture. So we're going to go through these actual transmutation reactions on what happens to a nucleus when it loses or gains alpha and beta particles. So a transmutation happens anytime radiation is given off. We call that decay. Or when radiation is absorbed by something else, we call that capture. That by definition is a transmutation. So these are kind of key words. Given off, decay. Decay means to break down. Capture means to take in, so you're going to absorb it. So in a decay or emission transmutation, the radiation is a product. In a capture transmutation, the radiation is a reactant because you're taking it in. So we do have to remember, there's always a way to check yourself. The sum of the mass numbers for the reactants must equal the sum of the mass numbers for the products. You can't lose mass, and you can't lose the number of protons. They just get transferred. So we can always keep track of kind of what's happening and make sure that, and double check ourselves to make sure that we're doing these correctly by just counting the number of protons and neutrons on both sides of the equation. So here's some kind of basic examples of how we're going to do this. So here's an example with alpha decay of carbon-14. Well, alpha particle, remember, is 2 protons and 2 neutrons. And so we're doing decay, meaning we're going to lose 2 protons and 2 neutrons from carbon-14. So carbon-14 is carbon with a mass of 14 and a proton number of 6. If it loses an alpha particle, what does it become? Well, it's going to lose 4 on the top, so it would go to 10 on the top, and it's going to lose 2 on the bottom and go from being carbon to beryllium. Beta capture is pretty much the same way. You just have to remember what a beta particle is. Beta particle is formed when a neutron decomposes into a proton and electron. So if you're going to make a beta particle, so if you're going to capture a beta particle, then you're going to capture a proton and you're going to capture an electron. So we don't really deal with the electrons or the charges, but because you're capturing a proton, your proton number goes up by 1. So it would go from being americium, which is number 95, it would go to Cm, which is number 96. So here's kind of the basics on that. A nuclear equation is what we were just looking at. That's used to represent a nuclear change, a transmutation reaction. And when you're writing a balanced equation, you have to remember that the total mass on the sides of the equation, on the sides of the arrow, must be the same. So we're not going to lose anything. We're just going to transfer something to something else. So alpha decay, alpha capture. This is kind of the basics of it. An alpha particle, remember, it's 2 protons and 2 neutrons, so it has a mass of 4. And it's going to have a charge of 2+. So if you lose an alpha particle, if you go through decay, you're going to lose 4 in the mass number and you're going to lose 2 in the atomic number. If you go through alpha capture, you're going to gain 4 in the mass number and gain 2 in the atomic number. So kind of the generic equation for it would be whatever you have, plus the alpha particle, or whatever you have minus an alpha particle. We will go through and write a generic equation in class. So alpha decay, alpha capture, here's some examples to do. Go ahead and try these out. What does this form? What does uranium-238 form if it loses an alpha particle? What does radium-226 form if it gains an alpha particle? So loses, meaning it's on the product side. Gains, meaning it's on the reactant side. So go ahead and try these. We're going to go through these particular problems in class together. I've also made an EduCreations video that you can go to watch me solve those problems. So again, here's some problems that we're going to do in class. We're actually going to do them on whiteboards. So you don't necessarily have to do them in your guided notes. We're going to do them together. So beta decay, beta capture. Beta particles have a mass and charge of an electron, so they do have a charge of -1, and they have no mass. So they're really not going to have much effect in terms of the mass, because if you decompose a neutron, so you lose 1 in the mass, but you gain a proton, so you gain 1 in the mass. So your mass number isn't going to change. What does change, though, is the number of protons you have. So when you go through beta decay, when you lose a beta particle, you lose 1 neutron, but you gain 1 proton. So your mass number stays the same, and your atomic number is going to go up by 1. If you go through beta capture, meaning you take it in, the number of neutrons goes up by 1, but the number of protons goes down by 1. Because to make a beta particle, you have to combine a proton and an electron together. Essentially, you're making a neutron. So still the mass number stays the same, but the atomic number in this case would go down by 1. So we'll write the generic equation for this. And then it's just a matter of simply going, okay, is it on the reactant side or is it on the product side? If it's going through decay, it's on the product side. If it's beta capture, it's on the reactant side, and then it's just filling them out. So in this case, this example right here, it's a beta particle capture. This would be a beta particle decay, so it's going to be on the product side. So go through these, and we will do them in class as well. We will go through all of these in class as practice problems. And again, I have made an EduCreations video that's linked on the home page of my website that you can watch to go through these particular problems to see how to do them. And then we're going to complete these in class as well on whiteboards. So these 4 practice problems we will do together on whiteboards. So transmutation practice here again is just filling in some of these equations. And these are outlined on your guided notes. So just filling in whatever it is that's missing from the equation, or writing the full transmutation equation for them, dealing with alpha decay, beta capture. We did not talk about gamma decay, but remember, when you lose a gamma part or a gamma ray, nothing changes because there's no mass to it. It's just energy. So you still have the same element. You still have the same number of protons, the same number of neutrons on both sides of the equation. You've just lost some energy from that. And so you would just draw it as, put the gamma symbol as a reactant or a product, but you're not changing anything. So we will do a bunch of practice problems in class over transmutation reactions.